Hi guys, welcome to my YouTube channel. Today we'll be looking at building distributed cache using C# from scratch. And so we're going to be looking at what a cache is, some very key concepts to learn first before we can start building a cache. So if you already have a background understanding of what a cache is, or you've used caches in your server applications, and this video would be exploring the depths of what the cache is and how to build a distributed cache, a very simple distributed cache. So a cache is stores frequently accessed data in memory to reduce access time. So a distributed cache spreads this caching system across multiple nodes. Those nodes can be inferred as machines or instances. So it makes it scalable and fault tolerant. So take for example, you have an application where you don't have data that is changing frequently, and you are accessing that data uh, in a variety of ways and frequently. So instead of making an IO call to your database, whether it's MS SQL or PostgreSQL or even MongoDB, you can have a caching layer that persists that data for a certain period. So that is the concept of caching. So there are key concepts you need to understand first before we get into building our distributed cache. So we have the in-memory data storage. So the data that is saved in the cache is saved on the RAM of the cache, which is the random access memory of that cache. So there is what is called the in-memory data storage, which is the use of dictionaries in the case of C# to store those data. So and they are stored in key value pairs. So you have a key and a value. So the key represents the identity for that particular object that you intend to store. So we also have, you need to understand concurrency handling. So using thread safe collections like concurrent dictionary in .NET or C#, we have a number of dictionaries. We have the normal dictionary, we have the frozen dictionary, we also have the concurrent dictionary. So we want a situation where we use a thread safe collection like the concurrent dictionary. So it handles everything around concurrency. Then there's data expiration. So implementing a time to live. So your cache has a period which is the time which that cache is available on the RAM. So your time to live can be 1 day, can be 5 minutes, can be 2 minutes, depending on your business requirements. So whatever business requirement you have will determine the time to leave expiration you're going to have. So there's also eviction policies like least frequently used, least recently used, and a number of eviction policies. There's also serialization and networking, consistent hashing, replication, and fault tolerance. So I'm going to be exploring a couple of what I've discussed right now in the project here. So it's going to be a hands-on, and it's a series. So I have part one, where in the part one I will cover everything around in-memory key value store. We'll deal with TCP communication between nodes, then using basic commands like get, set, and delete, then a simple consistent hashing or a round robin routing. So I'm going to be explaining all of that when I start building. So I'm not going to be doing any replication or fault tolerance for this particular project, or rather, yeah, for this particular series. We can maybe explore that in subsequent series. So let's get started. So first, we have this project, Ninja Cache project. It's a class library or a console application, and so I'm going to create an object. It's a class object. I'm going to call that our cache node. Now, inside our cache node, there are a number of things we want to have here. So I can say private read only, concurrent dictionary, which I already talked about, which is a collection for that improves or suggests thread safe collection. So it's a thread safe collection. So it has a string as the key and another string as the value for now. So let's initialize this here. Let's also have another field called TCP listener. Okay, let's call that listener. So let's have a constructor here. The constructor takes in the ports, the server ports, and we can say listener is a new TCP listener. Then the local address is set to any IP address, then the port that was specified. The server or the local address would be on localhost for now. Then we have, yeah, I think that's about it for here. So let's have a method. Let it be a task of start async. So this is where our caching server will be started. So first, we're going to turn on the TCP listener to listen for network requests. TCP stands for transport. Oh, it's not a transport layer security. So we have console the right line. And we can say cache node started on ports. Yeah, so it will give us that port where it was started. Then we're going to have an infinite loop. And what happens here? Let us say client awaits listener.accept TCP clients async. So we want to get all the pending network requests here. So we get the client. Then we also get the stream. The stream is the content of that network request. Stream is client.getStream. Yeah. Now we have a buffer. Now we want to write to the buffer. We want to write what is on the content of the network request on this buffer. So we can say new bytes. It's going to be a byte array of 1024 bytes, which is about a kilobyte. So what do? We would read the stream first. So we'll say, let's read from the stream. Await stream.read async. And we're going to read to the buffer throughout the length of that buffer. So what is happening here is, to be able to read from that network request that was sent, we need to read it into a byte array. So which is what we are doing here. So the next thing is, we can say, let us transform this into a base 64 string. So we can say requests is encoding.utf8.getString. In here we can, this is the buffer, and read, this is the offset, and this is the length we want to read through. Yes. So what this line here does, line 30, it says on that buffer where the network, the content of the network request was read into, read what is inside that buffer starting from the beginning throughout the end, because this is a 1024 buffer. So the content of the stream can just be, say, 200 or 300. So read from 0 till the end of that string. So that's what it does here. So then the next is we'll have a response. Now, whenever this is triggered, this read here is triggered, we're going to do something here. So we can say var response await handle. So this is where we're going to handle the request that we've read. So we can say requests, the network request. So say var response bytes is encoding utf8 dot get bytes. So we want to get the bytes from the response string. So say response here. Then we can now write the response on that string, or rather the response of the request that we've done. We can write it back into the stream, the network stream. So we write async. What are we writing? We are writing the response, that's the bytes. Then throughout from the offset, which is from the start of that string or the response, throughout the length of that response. So that is what we are doing here. So let us handle the function we created earlier. So it's going to be a private function, private async task of string handle request. So what are we doing here? So we're going to split the request. Now this request would be the syntax of the caching request that was sent, whether it's a set request, is a get request, or is a delete request. So the first thing we're going to do is we're going to split that string into different parts. So we say requests.split. So we split based on the space. So if there's any space in the string, we'll split that into an array, a string array. So after that, we're going to get the command, because we want to know if it is a get command, if it is a set command, or if it is a delete command. So based on the syntax, the first item on the string, on the parts array, should be the command. So we say var command is equal to parts. So the first item on that part to upper. So let's set it the case of that command to be uppercase. So next, I'll say I'll have a string response here. Let's have a switch case. So we're going to switch on the command. So based on the command, we can determine what to return. So if the case is a set, if it is a set, what do we do? Okay, we're going to save this inside a concurrent dictionary. Remember here, we defined a concurrent dictionary, a field here, and we initialized it as a store. That's the store for our data, the data that is supposed to be in our cache. So I'm going to come down here and I'm going to say set this store Now I can say dot add. I can say try add. What am I adding? The key and the value. The key here would be the second parameter or the second data inside the parts array. So parts array, the second data that is inside of it, that will be the key, and the third data inside of it will be the value. And then we can set the response to be okay, an okay response. Next, we can just break the switch case. Next case would be get. So inside our get, we would say the response should be what is inside the store. Let us try get value, and let us the key, as we've said earlier, is the path, the second data inside of the array, the string array, the second data, and we are going to get the value. So if we are saying if the value is not null, then return the value, else using our ternary operator we return null. So we can now break this case. The next, we can set a case for delete. So inside of our delete, we can remove the value based on the key. So we can say response is equal to the store. We can say try remove the key. The key, as we said earlier, is the second value inside of our concurrent dictionary. Out just this. So if it returns a positive boolean, then it was successful. But if it doesn't, then it means we couldn't find that particular key inside our concurrent dictionary. So we can say not found. Then we can break this case. Then we can have a default case. In case any of the commands do not match, we can say, what do you do? Return the response, set the response to unknown command, and break the case. Yeah, so we're good. We still have one squiggly line here. Okay, there's something we've not done yet. We need to return this task here. So we say return response. Yeah, we're good. So we look good here. Next, we're going to create another object. We'll call that our distributed cache manager. So I can come here and say add distributed cache manager. Okay, so first we're going to have a list or a collection of ports here. So I'm going to say private read only lists of ports. Okay, Next, we're going to have a constructor, and our constructor is going to take in a list collection of int. So int ports. Okay, so we're going to just assign that to this. We're good. Next, like I said, in this particular project, we're going to be creating a simple hashing algorithm. So for routing the what's it called, the data that we intend to save based on the ports. So we want to route to different ports. So we're going to be creating an algorithm for that hashing. So we're going to call this private int get node ports, and it's going to take in the key for that particular object we want to add to the cache. So we're going to say simple hash based routing. You can also implement a round robin algorithm for this, but I just want to keep it simple here. So I say int hash is math absolute, the absolute value of what the key, because now every string has a hash code. So we'll get the hash code of this string, of the key string. Then the next we're going to do is we'll say return ports, and what do we want to return inside the port? Based on the hash that we've gotten, get the modulus of the hash and the number of ports for that particular cache. So we get the hash here, then the number of ports, for that particular cache, we get the modulus, and using the modulus of that, we can get the position in the collection, the list of collection of ports that we can pick from. So next, I'm going to have another private method. Private async is a task that returns a string, and I'm going to call that send command. So it's going to take in what? It's going to take in the ports, and it's going to take in the command. So here we're going to say, we're going to using var clients, we're going to create what? A TCP client, a new TCP client. So the communication between nodes will be done using a TCP communication. So that's why we're creating a TCP client here. And the TCP clients would have a host, a local host as its server. Then we're going to set the port here. So after doing this, we can say stream, we can read the stream, client.get stream. So we can read the stream, that is the network stream, the content of the network request here. So we can say var data is equal to encoding .utf8 get bytes, yes. So the bytes would be the command, that is the command for the cache, the caching command. Is it a get command, a set command, or a delete command? So it will get that command, that is it will put it in a byte array. After putting it in a byte array, we want to write it to the stream, the network stream. Now when we write it to that stream, what will happen next is, you remember we already have a listener on each of the nodes, so it will listen for request on that node. So if this data that has been converted to a byte array is written to that particular string in or for that node, the particular port will catch it and will process it. So that's what we are doing next. So we're saying await string dot write async. So we want to write to that string. So we are saying we are writing this data, which is the byte array for the command. So we are saying all through, write all through the length of that data, write everything there. So we've written that to that string. So when we write to that string, if you come back here to this cache node, this is, you see that we have a listener waiting to listen. So the listener will read the network stream that was written from the distributed cache manager and process it further. So let's get back. So we say, and when he writes to that stream, it will keep waiting for response for the stream. You've written to the stream a request. You've written a request. Now you're waiting for a response. Now, in order to get the response, we say var buffer. We create a buffer, a byte array buffer. Is a 1024 bytes array. So we can get just the bytes for that buffer and say await string dot read. Now, what this read async here does is it waits for response from the write async. So when there's a response from our cache node that, oh, we've been able to process your request, take back a response because a response was written from the cache node. This is where we get that particular response. So when we read from here, we are reading what is on the network stream and we are writing it into the buffer. So the only way we can read it from that stream is from the buffer. So we're going to read throughout the length of the buffer. So after doing that, we can say return encoding.utf8 get string. So we want to get the string from that byte that was written to, or that it was read from rather. So we say buffer from the start of the buffer throughout. So we have buffer get, oh, we need to get string, not bytes. Yes. So we're good. So next, let us have our get, set, and delete methods. So let's first have our get, or our set rather, is an async task that returns a string, and we can say set string key string value. So first we get the ports. So based on the key that we want to persist our object against, we're going to do a hashing to get the port we want to save that particular object to. So we get the port using that algorithm, then we wait, and then we send the command. We send the ports and the get command. We say get the key. Yes. So that's it. Next we have our get method. We see public async returns a task, call that get. So the string based on the key, we can get the particular object we are persisting against. So we say int port, we can get the hash, or rather based on the key, we can get the exact port that that particular cache was saved in. So we say return await send command, and inside our send command we add the port, and we can see this gets, oh, here is supposed to be a set, pardon me, our set here supposed to be set the key with the value. Yes, so I get to just get just the key. Next, we can have our delete. Say public async returns a task, a task of string, and based on the key and our hashing algorithm, we can get the port for that particular node that it was saved on, and we can remove it. Await send command, and basically we are sending it to that port, delete key. Yeah, we're good. So next, let's configure the entry point of our console application here. So we want to be able to use the cache we created. So let's configure the entry points of our application. So you say class program. So let's have the entry point static async task main, takes in a string array of arguments. Next, let's have a list of tasks. So we want to add some task, or rather we want to add our cache to a task. So we say tasks is a new, we initialize that. Next we can say var, say let's have 3 cache. Now this is, it's not 3 caches, it's a single cache with 3 nodes. So let's create 3 nodes for our cache. So let's say let's call this node 1. var node 1 is new cache node. Let's assign the port 5000. Let's have another, or let's add task.add. We can add our node 1. Okay, I think we need to start this, yes. So start the cache, the node rather, the cache node. Then we can have another, a second node. Let's say node 2. Let's say on port 5001. Let's add that to the tasks.add node 2 start async. Let's have the second or the third node. You can have as many nodes as you want. So we have 5002. You can add disk, add. Okay. So node 3 dot start async. Yeah. So we've been able to add all our cache nodes to a task. Now the ideal thing you say is await the task, but if you do that, you will block the thread. Now the reason you will block the thread is because your TCP listener, or rather your TCP listener is listening for requests. So it's, that particular task is still running on that thread. The thread for the TCP listener is blocked, or rather the thread for the TCP listener has blocked the main thread. So if we do that, if we try to await the task here, we will run into that issue. So let's not do that. Let's just have a thread dot sleep. Let the thread sleep for 1 second. So the thread will sleep for 1 second to wait for the server to start. So we say wait for server to start. Next is we're going to initialize our cache here. So we say var cache is new distributed cache manager, and this distributed cache manager takes in a list or a collection of ports. So you can say new list for ports. Let's put, so we've already opened, we already have 3 nodes on 3 different ports. So we're going to add those ports here. So 5001 is one of the ports, or rather 5000 is one of the ports, 5001 is one of them, and also 5002. Yeah, so we've initialized our cache. Next, what we're going to do is we're going to set the cache. So we can say console.writeLine. What are we doing? We're going to set the cache. So cache.set. So let me just do this first. Set cache. So next we're going to have this and say cache.set. So what is going to be the key? Let's say our key is user1. So user1, then the value for that key would be, I'll call that Gabriel. So I'm saving a value or a data, which is a string called Gabriel, and I'm assigning that to a key called user1. So next I can have another console, right on the console, and I can say this is our get cache. So get the cache, the key. Okay. So we can get the key here. Then let's also delete from our cache. Delete from cache. So we can delete this key. Let's set our delete. Then we can try getting the key from the cache again. Let's see if that works. Yes, so that's about everything we need to get started using. And let's not forget, this is an async. The set is an asynchronous method. So let's not forget to add our await, 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 await. So we're going to try to run this right now and see how it behaves. So it's going to start right about now. Okay, so we see our cache nodes have started on port 5000. So our set, we're able to set the cache. Okay, we see we're able to also retrieve from the cache. We're able to retrieve what? The value which we stored. The value we stored was Gabriel. We're able to retrieve it from the cache. Then we're able to also delete from that cache. And when we try getting from the cache for that particular key, we saw a return null. So that works really good. So what is happening here? So in this project we've built, we have a 3 in-memory cache running on different ports. Now, this data now that we are persisting on that concurrent dictionary is actually saved on the RAM. That is why it is faster than making an IO call to your database, because the database is trying to retrieve from the disk. But for caches, the data are stored on the RAM. So there are positives and negatives It's not a shiny bullet. You just need to know when to use it and how to use it. So, like I said, what's happening here is we have three in-memory caches running on different ports. So those caches are called nodes. So we have three nodes. We have node running on port 5001. We have another one running on port 5000 and port 5000, port 5001, and port 5002. Now we have a distributed cache manager that routes the key to one of any of these nodes based on the hash. Like I said, we had a node hash that we set. So based on the key or the hash that was generated for that key, it routes it to a node. So that's how the so when you're setting, you route it to the node to know which node to actually persist that data. Then if it is retrieving, it also gets based on that key, it knows the node to actually retrieve from. Next is we are sending the commands using a TCP connection. So that's we are doing that to simulate internode communication. So what happens is there's a TCP listener on each node. It is listening for requests on that particular port. So whenever we send a request, say we are setting a request. What we are doing is we are we are creating a TCP client and we are sending streams, network streams to those nodes. Now, those nodes will read those streams, perform the action, and write back to the stream. The stream will write and wait for a request or response and get the response and then display. So that is what is happening here. So that's about everything you need to know for building a distributed cache. Not possibly everything. There are other things we didn't have here. There are things like TTL, that is the expiration logic with a background thread. There's also replication between nodes. You can also add an HTTP API on top. Then you can also use JSON or protobuf for structured messages. And yeah, that's about it. So in the next video in our series, we'll be looking at some other aspects of the distributed cache so we can make our cache more robust. Yeah, so that'll be all for now. Thank you.